Hi AppSec engineers, welcome to another video of Security Engineer Interview Questions. In this video, we'll be looking at a very important network security and isolation feature within AWS called the VPC. Specifically, we'll be focusing on VPC flow logs. One of the common questions that they ask in interviews is, what kind of methods do you have to monitor VPCs or monitor traffic within the VPCs? And VPC flow logs happens to be a very useful and very critical feature that can help you supercharge your network security on AWS. So without further ado, let's get started with understanding about VPC flow logs. Let's go. We're going to be constantly putting out content on AppSec, cloud security, container security, DevSecOps, and Kubernetes security. Now, if you like this sort of content, you should consider liking and subscribing to this channel on YouTube. In addition, it would be great if you could follow us on Twitter and on LinkedIn. Before we get started with VPC flow logs, I just wanted to mention that this is a part of our learning path, which is AWS Security, and we have a very specific course that covers all of this material and more in our AWS EC2 and Network Security class. So if you're interested, do check out these classes and tons of more options that you have for learning on AppSec Engineer. You get access to the hands-on labs, you get access to amazing material that we constantly update and add new content all the time. So do check out appsecengineer.com and let us know what you think of our AWS security classes. Flow logs is essentially a very important feature that allows you to capture network traffic that's going back and forth from a network interface on a VPC or a bunch of network interfaces on a VPC. So you have a VPC, we've already spoken about the virtual private cloud, but you also need to be able to monitor traffic inside that cloud environment, on that cloud network. VPC flow logs can help you do that. Now, these flow logs are essentially network layer flow logs, which means they can allow you to get information on the kind of traffic that's going back and forth. They won't give you a traffic dump. For that, you'll probably need something like a VPC mirror, which is a lot more application centric. But VPC flow log still gives you an idea of what kind of traffic you're seeing and what kind of ports and services are being accessed in your VPC or within a certain network interface within your VPC. So you can use this for analysis of your firewall rules or security group rules. You can monitor basic network traffic with a VPC flow log. And you can also determine the type of traffic patterns and the type of directions on which traffic is flowing within your VPC or within resources within your VPC. So it's very useful to have VPC flow logs configured as part of your VPC, especially if you want to get this kind of analysis that you can do against that particular VPC. The other thing with flow logs is that all of this network traffic capture is done outside of the network. So which means that you're not seeing any latency or additional performance issue by just using VPC flow logs. So that's something that you are seeing with VPC flow logs, and it doesn't require that you have this performance impact on enabling VPC flow logs in your VPC. So that's very important for you to consider. When it comes to where VPC flow logs can be applied, it can be applied for the entire subnet, it can be applied for the entire VPC itself, or it can be applied on a network interface in a VPC subnet. So you can just apply it to a single network interface and it will capture that network interface flow logs in the VPC flow log. So you can essentially specify all of this when you are creating that flow log. So when you're creating that flow log, you're essentially creating it against a set of resources. So what resources are going to be captured as part of this flow log? The entire VPC or a network interface or a subnet? What do you want captured? What type of traffic do you want captured? Do you want all traffic? Do you want only accepted traffic? You want only rejected traffic? So let us say you want to get an idea of what kind of rejected traffic you're seeing. You might just decide to filter out and get only the rejected traffic. The other important consideration that you have with VPC flow logs is where you're publishing them to. Now you can publish them to an S3 bucket, which we're going to be doing in our lab, or you could publish them to a CloudWatch log as well. Now, what we are going to be doing is publishing them to an S3 bucket and we're going to be querying them like you query a database with another service called AWS Athena. So we're going to be using Athena to query the S3 bucket, which is essentially going to be stored as a JSON set of flow logs. We're going to query that S3 bucket and find it. So I like to use that because you can do all of that analysis with AWS Athena, but you can also do a very similar set of analysis with CloudWatch Log. So you can write CloudWatch Log queries, and you should be able to do some kind of analysis with CloudWatch Logs as well. If I'm not mistaken, I think CloudWatch Logs, the option may be a little bit more expensive than the S3 option, although I'm not 100% sure about whether it actually is. Now, when it comes to the flow logs itself, this is what you're looking at when we have flow logs. So flow logs do not really capture the entire packet or do not capture the entire contents of the traffic, but more metadata: the source address, the source port, the destination port, the start time in Unix timestamp, the end in Unix timestamp, the protocol, the number of packets that were sent, the number of bytes that were sent, the destination port, the destination protocol, the number of bytes that were sent to the destination. All of this is essentially captured in your VPC flow log. Source information and destination metadata information is captured in a flow log. So you're not going to be able to, for instance, let's say you want to check whether the traffic has some kind of malware in it, you're not going to be able to do that. For that, you probably need a VPC mirror where you are analyzing traffic after the fact, like an IDS or something like that. This is not that. This is essentially more a metadata monitoring kind of a thing where you are trying to see whether these kind of traffic patterns actually make sense or whether they are anomalous or whether they are actually part of your defined capability. So that's really what we're focusing in on here when you're doing your field mapping for your VPC flow logs. Now, there is also certain type of IP traffic that is not captured. So this is layer 3 stuff, IP traffic that is not captured. So things like DNS queries to the Amazon DNS service, not captured. DHCP traffic when it's trying to figure out the create leases on the network itself is not captured. When a Windows server that you deploy inside AWS is talking to the license activation service, it's not captured. And so one of the other thing that's also not captured is access to the metadata URL. So we've been speaking about metadata in the EC2 segment where you can access the 169.254.169.254 service. That traffic is not captured here. And there's also another internal network interface for the Amazon time sync. So this is like an NTP service that Amazon offers that is also not captured. And reserved IP addresses that are meant for the VPC router, that is also not captured by your VPC flow log. So this is something that you need to understand about VPC flow logs. These are some of the benefits and of course some of the limitations that it has, and you can implement it depending on your use case. And we are going to be looking at a case study where we are going to implement it on an environment and we're going to query it with Athena because we're going to store all these flow logs in S3 and we're going to query it with Athena and try and find some anomalies in our traffic and try and lock it down after the anomaly is found. So this is something that we're going to be doing in a subsequent lab. Now let's look at the VPC case study that we're going to be looking at and implementing flow logs on. Let's actually explore what it is that we're trying to achieve with this case study. So we have a VPC that you've set up. The stuff in the gray background is essentially the VPC. Now the VPC in this case has two servers. One is a web server, which has our application, and the other one is a Redis database, which is a database. Now, all of these applications are talking to the internet via an internet gateway. However, somebody who's administering or configuring this VPC has made a mistake where the Redis server has been put on or been exposed on a public subnet, which means that the Redis server, which is a database server, is now accessible from the internet. Now, what the attacker is going to try and do now is going to add their Redis machine from the outside as a slave to this Redis server or as a secondary server to this Redis server and start to pull out sensitive data from this Redis server. So that's the case here. Now we're going to try and use flow logs to be able to determine the anomaly. So what we're going to do is all the traffic that's being generated within this VPC is going to be captured as flow logs, which is going to be pushed into an S3 bucket. What we are going to do from that point onwards is we're going to use a service called AWS Athena, which allows us to query these sources like S3 or these other file sources and be able to identify this anomaly in our security. And hopefully, of course, after that we'll be fixing it. But the idea here is to first look at VPC flow logs and see how we can use a service to be able to determine these kind of security exceptions or anomalies, and then maybe we can take some action around patching it or putting it in a private subnet and restricting it with additional security groups and so on. So this is our case study. It's a simple case study, but this is a very common misconfiguration that happens. But you can see that using VPC flow logs, we should be able to determine this pretty quickly as we're getting into this case study. So let's see this in our next lab. Let's get started with our lab on VPC flow logs. So if you've looked at our case study, what we want to do is essentially set up a couple of servers, and we are going to set up an internet gateway. Now, one of the servers, which is a database server, should not be exposed to the internet. However, because of a configuration error that our administrators created, it's exposed to the internet, and we have a problem. So somebody can directly access that database server and then potentially compromise it and then add it as their secondary server and start to exfiltrate data out of that server. Now, we aim to catch or at least identify all of these anomalies with VPC flow logs. Let's look at how we can apply VPC flow logs on our example and then see how we can get it to work. So this is how we're going to be doing it. Let's look at the code itself. Now we're going to be using Terraform for this. It's a single Terraform file. It's not very complicated. Let's talk about what we're doing here. We're going to be configuring this on the US West 2 region. We're going to set up a server for our application, which is a Golang application. And the second one, we're going to set up a Redis database. So we're going to be running both these servers in our VPC. You will see that we've created an internet gateway for these servers to gain access to the internet. We've also created a route table, a subnet, and so on. So we've only created a public subnet. We've not created a private subnet. So that was the first mistake that we've made. So we've created the public subnet and not the private subnet. And we have set up some rules here. Port 22 SSH is allowed. Port 6379, access to Redis is allowed, which is again a bad thing. We don't want access to Redis from the outside, but somebody has made a mistake. They've added an ingress rule. So the idea here is that we're going to set up this interface. Us as the attackers want to try and add ourselves as a Redis, add that Redis server as a secondary or a slave database, and then we're going to try and identify these anomalies with our VPC flow logs. Now, the configuration for our VPC flow logs, now let's look at how this is going to work. So what's happening is that we have a flow log set up for that particular VPC, which is the new VPC we create. And all of the flow logs are going to be pushed into the Amazon S3 bucket. So Amazon S3 bucket, you'll see that we've created a new Amazon S3 bucket, and we're pushing all the data into this particular bucket and all traffic. So remember, VPC flow logs, you are allowed to capture different types of traffic patterns, accepted, rejected, all. We're deciding to use all types of traffic. So this is what we're going to do. And then we're going to query this with a service called Athena to identify the anomalies, identify traffic that is not meant to be accessible in this particular case. So let's actually go ahead and deploy this. We're going to use the next video to go ahead and deploy this application and actually see how you can work with flow logs in this particular case. Now that we've looked at the code, let's actually go ahead and deploy our stack with the servers and the VPC and the flow logs configured. Now, this is a pretty simple example. So you will see that you just have to go into the VPC flow logs directory, do a Terraform init that will initialize all the providers that we need for this, which is the random TLS, local, and AWS providers. And finally, we will need the last one, which is going to be actually Terraform apply auto approve. Now, this should deploy on our environment, and you will see that it starts to deploy on our AWS environment. A VPC is created, and it also creates the subnets. It also creates the instance. It creates the gateway. It also starts to create the servers. Remember, there are two servers. One is just a very simple Golang application that's running on one server. The other one is a Redis server, which is supposed to be ideally in a private subnet without external access, but somebody has made a mistake. They've configured it on the public subnet with external access with a security group rule that allows access to 6379. So this is obviously not great. So it seems like some test configuration has made its way to prod, and this could result in that server getting compromised. Now let's see how we could potentially compromise the server. So it's all of this is getting created. We're going to wait for it to finally get done. And I'm going to fast forward to the point where the stack has been completely deployed. Now the stack has been completely deployed. So let's look at what we have in terms of outputs. So the outputs are quite useful for us to understand. First of all, we'll see that we have two public IP addresses, one for the Golang app and one for the Redis database. But the more important thing for us to note here is the private IP addresses. So the private IP address, one is for 172.16.10.101 and 172.16.10.100. Now the idea is that the traffic that is going into the Redis IP should only be from within this subnet and not outside of it. So the idea here is that we are going to use our VPC flow logs to be able to identify this sort of traffic and identify any anomalies, to say that if traffic is coming from outside of these IP addresses 172.16 and 172.16 in this case, if there's anything outside of this range, we're going to be able to identify an anomaly with our VPC flow log, and maybe after that we can take a call on shutting that kind of traffic down. Now we also have the public IP. So let's say I'm an attacker, I've found the public IP and I'm going to try and exploit this. Now a very common Redis exploit is to add a database. So let's say I have a primary Redis database running. I want to add that Redis database as my secondary or a slave database. So I'm going to add that as my secondary or the slave database, and let's see how that's going to pan out. So I'm going to be running my Redis slave or the secondary database to add itself as the secondary database to the primary that is running on this. So it's essentially like adding a add-on database to the Redis primary database that's running on this particular public IP. That would obviously synchronize all the data, so it would actually pull down all the data from that Redis database to this local copy of the Redis database, which would be a complete data exfiltration at that particular point in time. So let's do that. I'm going to be running this with Docker so that it's just easy for me to run instead of installing all the Redis dependencies. You can see that it's connected successfully. It's actually started doing the master replica synchronization, and it's actually successfully done that, which means that at this point, I have completely compromised that Redis database. And since it's publicly available, I've been able to access it, and I can maintain persistent access to that Redis database. However, the idea here is that we want to detect this. We want to be able to use some kind of our tool to be able to detect this and find this anomaly in our deployment. So that's where we go to our VPC flow logs. Our VPC flow logs have already started getting populated in our S3 bucket. In fact, if you go to S3 and if you look at the S3 bucket that we are going to have our flow logs in, you will see that it already has some data that has already been populated. Now let's actually see this. You'll see that we have our AWS logs directory here, and you will see that we have our flow logs for West 2, and it's already started getting captured. So you have all this data already in the log.gz. Now, one way is, of course, you can pull out these VPC flow logs and then start to analyze them manually or use some kind of JSON analysis tool to do that. But we're going to be using a tool called Amazon Athena. Athena allows you to query this file or these sets of files. You can actually query these sets of files and you can actually get all that information directly like an SQL query. So I'm going to copy this location of those files wherever they're stored. So I'm going to copy it to the point of US West 2. And then I'm going to open up Amazon Athena. I'm going to query data in S3 like we query it with SQL. So this allows you to query S3 data like you would query SQL. So all you have to do is set up some kind of schema and you should be able to query this data quite easily. Need to be in US West 2, which is Oregon, just changing the region. And once we do that, we're going to first create a table, and then finally we're going to run queries against that particular table. So when you're running Amazon Athena, you need to set up a query output path. So I'm just going to create a query output path in Amazon S3. Let's call this AppSec Engineer. You'll probably have to name it something unique. So I'm just naming it AppSec Engineer query output. And we're going to be using this in order to actually route our Athena query. First of all, just go to Athena, and in Athena, you will have an option called settings. Now in the settings, you have to go ahead and set your query path. So basically you should have that. And now you can create your table and get started. So the query is created. You've created a table called VPC flow logs. Now VPC flow logs are going to be queried from this source, which is our S3 bucket with all of this data. So you have all of the log data already in S3 buckets. So now that we have created our query, we're going to have to make a small change to our table. We're going to have to add a partition that will allow us to query it by date. So that's what we're going to be doing now. So I'm just going to open up a small file here and make some changes to my query so that I can effectively query it by date. So you see that I've done this particular, so it's going to alter the flow log table by this particular current date. So we're going to change the current date. In this case, the current date is 28. And we are going to just change the bucket name and so on. So those things also you need to do. Make sure that we change the bucket information. We're going to change the S3 bucket information here, as you see. And we're just going to add the query format again, 2020, 12, 28. So we're going to be adding this. Now we're going to copy this query and paste it in Athena, format it, and make sure that it is correct before we run it. Let's run the query, and the query is successful. So now we have had a partition. So each partition will have this date. So you can actually query by date. Now, finally, we are going to actually query the VPC logs and find wherever traffic is not coming from the 172.16 IP range. So what we're going to do is we're going to add a query like so. So it's going to look for VPC flow logs where action is accepted. So all the accepted traffic where destination address is our Redis internal IP address, but the source address is not something like 172.16, which means that if it's coming from any source outside of the 172.16 IP range, show me that traffic. So you'll see that what we've done is we're using a select query where we're selecting the VPC flow logs where action is equal to accept and destination address is the Redis database. So we want to find all traffic going to the Redis database where the action is accepted, where it's accepted traffic and the destination port is 6379. So the Redis database on this IP and this port, but we are also filtering for a source address that is not from the internal IP range. So not from 172.16. If you have any such traffic, show me. And when we run the query, you will see that the query gives you this particular response. It tells you that, hey, you know what? Somebody from this source address is accessing Redis on port 6379, and this is all accepted traffic. So you can see that we've been able to identify that somebody outside of the network who's not supposed to be accessing this has had access to this and has been communicating successfully with the Redis database. So with this, what we can do is potentially shut it down, of course, put some security groups around it, put it in the private subnet. We can do all of those things. But VPC flow logs is extremely powerful for you to be able to proactively query for such things, even create dashboards for such things based on what you have, and then you can go ahead and take some corrective actions once you actually patch the security flaw. So this is a great example of how you can leverage VPC flow logs, and this example talks about how you can leverage it from the perspective of services that should not be exposed externally but are for some reason. So that's something that you can do with VPC flow logs. We're going to be constantly putting out content on AppSec, cloud security, container security, DevSecOps, and Kubernetes security. Now, if you like this sort of content, you should consider liking and subscribing to this channel on YouTube. In addition, it would be great if you could follow us on Twitter and on LinkedIn.